Here's example 6 of applications of trig. So this is another example of solving a right triangle. So again, solving a triangle just means you are given some of the sides, some of the angles, and you use the given information plus trig functions to find the missing sides and missing angles. Okay. So here, and if you want a copy of this worksheet to follow along with, check the video description. There's a link in there. You can click that link and get a copy of this worksheet. So example 6, in triangle ABC, little a is 4, little b is 3. Big C is 90 degrees, okay, so that tells us it's a right triangle. And we want to find the values of little c, capital A, and capital B. Okay, okay, now let's go ahead and draw the triangle. So we know it's a right triangle because we were told that we were told angle C is 90 degrees, so here's our C. And again, the custom is, so let's just call this one A and this one B. Can we call this one A instead, that one B instead? Yeah, why not? But it's already written down like this, so A, B, C. So the custom is for the angle that you have, so angles are denoted with capital letters, and the side opposite is the corresponding lowercase letter. Okay, so if this angle is capital A, then the opposite side, this side, is lowercase a, and we're told that lowercase a is 4. So this guy is 4. If this angle is capital B, then the opposite side is lowercase b, which we're told is 3. If this angle is capital C, then the opposite side is lowercase c, which we need to find. Okay, so there's lowercase c. All right, now how do we find C? So, and A and B basically. So we're given angle C, we're given this side and this side. So it's a right triangle. One side is 3, one side is 4. This might jump out at you as a 3, 4, 5 Pythagorean triplet. So if you have a right triangle where one leg is 3, the other leg is 4, then the hypotenuse has to be 5. But if that doesn't jump out at you, just remember the Pythagorean theorem, c squared, in this case, c squared equals a squared plus b squared. Okay, so c squared equals 4 squared plus 3 squared. And then c squared equals, 4 squared is 16, 3 squared is 9, so then c squared equals 25. So if c squared is 25, then c is 5, right? Take the square root of both sides and we just get c equals 5. Now I'm always saying that when you take the square root of both sides, you should take a plus and a minus, but we're talking about the length of a side of a triangle, so that cannot be negative. So technically, yeah, there's a positive root and a negative root, but the negative root doesn't make sense here because again, we're talking about the length of the side of a triangle, so it cannot be negative. So c has to be positive 5. Okay, so little c is positive 5. That's one of the things we're looking for. Now we need to find capital A and capital B. So again, what's nice about this is it's an exact value, not an approximation, so it's safe to use that to find other things. Because like we mentioned in the previous example, we want to avoid using approximations to find other values. Because if we use an approximation to find something else, then that something else might be less accurate than it otherwise could be. And we don't want to do that too much. So anyway, now we have all 3 sides of the triangle and we have one angle is 90 degrees. So what can we do? We can just start using some trig functions. So we could say, okay, tangent of B, okay, the tangent of B is opposite over adjacent, right? Opposite over adjacent. So the tangent of B is 3 over 4. So how do we get B from there? Well, we can just take the inverse tangent of both sides. So if we take the inverse tangent, then we get B equals the inverse tangent of 3 over 4. Okay. So why is it okay to do that? So in case you're wondering, you know, remember inverse trig has all those crazy rules and restrictions about where you can do this and that, and you can only do the inverse tangent of the inverse. They only cancel, or rather, the inverse function applied to the function. They only cancel each other out on a certain interval, a certain domain and range, and all that stuff. All those restrictions to worry about. But what's nice is because we're dealing with right triangles, we don't have to worry about any of that. Okay, so tangent of B equals 3 over 4. Because we're in a right triangle, we can just safely say that B is then therefore the inverse tangent of 3 over 4. Okay, so in other words, we can just take the inverse tangent of both sides, and then inverse tangent of tangent, they'll cancel each other out, so to speak, and we'll be good. We'll just have a B left over here. So, and again, it's safe to do that because we're in a right triangle. So that's good there, that's great. And all the angles are acute, or angle A and angle B are acute. That's why we can just worry about that, because they're between 0 and 90 degrees, so that's good. Okay, anyway, now we can, so just some details of why it's okay to do that. Let's zoom in here, and we'll see what that is. So we want the inverse tangent of 3 over 4. Make sure that we're in the degree mode, because angle B, we want the answer in degrees, okay, because we're talking about angles in a triangle. So we should answer in degrees. Also, angle C was given to us in degrees, so we should answer in degrees. So we just want the inverse tangent, make sure we do inverse tangent, of 3 over 4. And that's approximately equal to 36 point, let's say 87 degrees. We'll just round to the second decimal place. So 36.87 degrees approximately. Okay, so B is therefore approximately 36.87 degrees. Okay, now how do we get capital A? That's the last. So we have little c, we have big B, now we need capital A. So we'll just do the exact same thing. So tangent of B is opposite over adjacent. Tangent of A is also opposite over adjacent. Okay, so, but for A, the opposite side is 4, the adjacent side is 3. So tangent of A equals opposite over adjacent. Okay. So just like before, because we're in a right triangle, we can just take the inverse tangent of both sides, and we'll have A equals inverse tangent of 4 over 3. Okay. So I won't go through the explanation again, but it's basically just because we're in a right triangle, it's okay to do this. Take the inverse tangent of both sides and nothing crazy is happening. So let's put that into a calculator and see what we get. So what we want to do is the inverse tangent of 4 over 3 now, and again, make sure we're in degree mode. So this is approximately 53.13, round out to 2 decimal places, 53.13 degrees. Okay. So then we get A is approximately 53.13 degrees. Okay. And that's our answer there for A. So that's pretty much it for example 6. One thing I want to point out though is when we got capital B, it might be tempting to say, okay, well now I have B and I have C, so I can just say A plus B, B plus C equals 180 degrees, right? And then I'm given C, it's 90 degrees, and I just found out B, it's approximately 36.87 degrees, so I could use that to find A. And, but like we said, we want to avoid doing that because B is an approximation, okay? B is an approximation, so we don't really want to use it. Now a counter argument could be, well, they all three have to add up to 180 degrees anyway, so maybe it's better to do it this way. But on the other hand, it's a bad habit to get into. So B is an approximation, and it's a really bad habit to get into to use an approximation unless you absolutely positively have to. Okay? So 36.87 degrees is just an approximation. Now we could do this again with the inverse tangent of 3/4 in this equation, but that would be just kind of overkill, really messy. We don't really want to do that. But anyway, but also probably what's worth pointing out is if we did this with 36.87 degrees, we would actually get the same answer, which is just a happy or unhappy, however you think about it, coincidence. Okay? It's a happy or an unhappy coincidence. 53.13 degrees is what you would get if we did it this way too, using the approximation. So even though you'll get the same answer, the same approximation for A, it's still not a good habit to get into. So we should avoid using approximations to get other values. Avoid that wherever we can. Okay. So anyway, little c is 5, capital B is 36.87 degrees approximately, and capital A is approximately 53.13 degrees. So that's it for example 6 of applications of trig.